Hey there. So for this question that you're asking, there's a little bit of a part was a bit confusing. It says decreases. So we want h of 1, sorry, h of t, and we know that's a hyperbola function, but we want h of 1, so a new function such that this condition is met. Now, when you work out that condition, h of 0 is just 3,000. So if you sub 0 there, that just becomes 3,000. So it's really saying for this new function, when t is 0, then the y value is 3,000. So there's a condition that it has to meet the y-axis at 0, 3,000. And the second thing that it's sort of saying as well is that it will decrease at half the rate of h at any point in time. Now, when I read that, that means if it's going to be half the rate of whatever h is, it means it's going to grow slower than h. So it means that if the original h, let's say it was at 2,000, so it decreases and it's gone down to 2,000, then h of 1 will decrease by half of that. So if it went from 3,000 to 2,000 for h, that means it's a drop of 1,000, then h1 will drop half of that at any point in time. So instead of dropping down by 1,000, it will drop down by 500 instead, because it's half of whatever the decrease is. That's what that's saying. So if that is true, then technically, and I've drawn it on a graph so that you can see, that means it's actually halving whatever because it's growing out slower, it's actually getting stretched out horizontally. Because if one is dropping down like this, the other one has to drop slower. That's the only way for you to be half that rate. So if this drops by 1,000, the other one has to drop half the rate at the same point. So that means it has to be 500 here. So that means it takes longer before it actually finishes, whereas the first one would drop down much quicker. So because of that, that line there already suggests that it should just be a dilation of factor half, or technically, half, but from the y-axis. So that means that it will just be h of t of 2. So you can see here when I draw the graph. So this is the original graph, okay? And if I put x2, that's how you make it wider and longer. But the problem to that is the question wants you to state 2 transformations when they only really gave you 1. Because that's the only way to maintain still 3,000. So notice that 0, when x is 0 or t is 0, it's still 3,000. So to keep it the same, technically you only need to do 1 dilation. So what there maybe potentially the question was written was that they wanted you to do 2 transformations. So how can you still do it and still halve it? Well, you can also halve it vertically as well. But the problem is if you halve it vertically, meaning it's a dilation of factor half from the x-axis, right? So now it's a vertical halving, so the rate of drop is halved, then it's half of h of t. And if you do that, that's a problem now, because if you do that, can you see the graph for the green graph? Now the y-axis is different because you're affecting the y value. So from 3,000, where the y-axis intercept was 0, 3,000, it should now be half of that, which is now 0, 1,500. See that? So this is the new y value. So because you want to match, you need to meet the first condition, which is 0, 3,000. That means if you were to do half of h of t, rather than just doing h of t on 2, which fixes the problem already, so you're half the rate and you also meet 0, 3,000 as the y-intercept. With this change, you still get the half the rate, which is true, but you then need to make sure to get 0, 3,000. But at the moment, it's 0, 1,500. So the only way is you have to then do a vertical shift. You have to shift this graph up by an extra 1,500 to match. Get me? So that's the only way to hit 0, 3,000 if you shift the graph up by 1,500. And that's the only way to maintain half the rate, but also hitting 0, 3,000. So what it's saying is that's what the new transformation graph should look like. So there were two possibilities there, but because they said two transformations, it makes it a bit confusing because the language says decreases half the rate of h at any point. So I would have thought it was this one. But since it says two transformations, so essentially this is what you're doing. You're saying the original graph h of t, you want to map it now to the new h1 of t, which we just figured out was half of ht 1500. Okay? Or if to make things easier, let's call this y, and then let's call this y dash. Okay, so what I'm saying is y is equal to 3000 over t plus 1. We're trying to map that to a new equation where we know it's 3000, sorry, it's half of 3000. So half times 3000 over t plus 1. Okay, so that's your h of t. So that's your half, that's your h of t. And because we're doing this dilation, we know that we actually have to shift the graph up by 1500. Otherwise, the y values won't match at 0, 3000. Okay? All right. So now how do you do the transformations? Well, this is pretty straightforward. We need to map the y's with the y's. And so how do you do that? You bring this one across. So it becomes y dash minus 1500 is equal to half times 3000 over t plus 1 times 2 to both sides. So you get 2 bracket y dash minus 1500 is equal to 3000 over t plus 1, right? So now we can match them. We can say original y is equal to this. This is what you substituted with, right? And then original, sorry, I should have put a dash for t's. So this is new t, new t, new t. So then we also have old t is equal to new t. So those two match. So if we put them together, this is what you get. You get original y is equal to 2 bracket y dash minus 1500. Whilst the other one is t plus 1. Original t plus 1 is equal to new t plus 1, which interestingly enough, which we can clearly tell because it's all vertical transformations, no horizontal transformations. So it cancels out and it just becomes t equals t dash, right? Which we can already see. Nothing has changed for the horizontal transformation. It's only the vertical. Now, here in the vertical part, there are two parts here. Because remember, we're trying to find the transformation. So we're trying to work out what y dash equals to. You got two ways to do this. You can divide both sides by 2. So it's original y divided by 2 is equal to y dash minus 1500. And then add 1500 on both sides. So you can have this as your transformation. Okay, so what we're saying is x, y original becomes x dash y dash. Well, in this case, we know that x dash is still the same as x, and y dash is actually now equal to half of y plus 1500. So what is this? What's my two transformations? It's dilate factor of half from the x-axis and then translate up by 1500. Okay, or instead of doing it that way, you could have set it from this step here. So let's do it again. So from this step, you could have kept the 2 there. And so you could have expanded the brackets and you would have got 2y dash minus 3000. And so if you rearrange it to find y dash, you could have got plus 3000 on both sides. So you then get y plus 3000 is equal to 2 y dash. Divide everything by 2. And again, you get that half the rate of y plus 1500 is equal to y dash. And so your transformation, x, y coordinates becomes x dash, y dash. And you can see x dash, which we already knew, is going to be the same. So it really becomes x dash is half of y. Wait, sorry. Wait, something's a bit odd. What did I do? Oh, sorry. I jumped the gun here. Whoops. Divide this by 2, divide this by 2, and then divide this by 2. So that means the transformation here is adding 3,000. So go up by 3,000. So you got y plus 3,000 first, and then you divide it by 2. So the transformation is you could also translate up first by 3,000 up, and then dilate factor of 2, or half, sorry, from x-axis. So those are your two possible answers because they wanted 2 steps, 2 transformation steps. Otherwise, technically, from what I understand, it should have just been t over 2, and that would have solved the problem. Okay, so I think this one is a poorly written question last year. I think Mr. Bagier agreed with that one too. That decreases at half the rate of h at any point in time. Can be read in many ways, like 2 different ways there, but I think maybe the examiners were just focusing on the fact that it's half of whatever h of t is in the y value sense. When I read that, it sounds more like it's trying to say halving it. So if it decreases slower because it's decreasing by half the rate. So it's kind of like saying if I was losing money and you're losing at a rate of half my money, then, if I'm losing $10 and you're only losing $5, so it means that you should lose money less or slower than me. Whereas this one's implying, this one. This is also implying something similar, but this is more like reducing in population. So if my population was 3,000, then your population is decreasing at half the rate of h. So whatever h is, I'm now going to be half of that. So if you're 3,000, I'm 1,500. So it's sort of a set up for interpretation. I think it's a bit poorly written there. So that's tricky. But I think, if anything, this still gives a hint on what you were meant to do anyway, because with the first go, there would have been 1 transformation needed, whereas this one means you're going to have 2. So it had to be this one. Okay, hopefully that makes sense there, but that's how, I think your question was, how do you do it using the dash method? Well, this is the dash method that I just did here. I just went original to new, and our goal was to find y dash. So as long as you match the y's and the x's together, then everything else should follow. Okay.